to PolyUrethane and augmented role of automation in chemical industry, organized by Department of Chemical Engineering, St. Joseph College of Engineering, Chennai. I especially want to welcome our guest as well as our alumni, Mr. Pradeep Murali, working as a plant engineer, Isotech International Incorporate Company, Atlanta, Georgia, USA. Our HODs, Dr. R. Bhaskaran sir and Dr. N. Venkatesh sir, my colleagues and participants from various institutions. To start with, polyurethane is a polymer composed of organic units joined by carbamide links. Most polyurethanes are thermosetting polymers that do not melt when heated, and thermoplastic polyurethanes are also available. Polyurethane polymers are traditionally and most commonly formed by reacting di or triisocyanate with polyol. Since polyurethane contain two types of monomer which polymerize one after another, they are classified as alternating copolymers. Polyurethane are used in manufacture of high resilient foam seating, rigid foam insulation panels, microcellular foam seals, gasket, spray foam, durable elastomeric wheels, tires, automatic suspension, bushings, electrical compounds, high performance adhesives, surface coatings, sealants, synthetic fibers, carpet underlays, hot plastic parts. Our guest will explain about the application of polyurethane in chemical process industries. Now, I will hand over this session to our guest, Mr. Pradeep Murali.
Thank you, Professor Karthikeyan. It is a pleasure and an honor to be here. Thank you, HODs, Dr. Bhaskaran sir and Dr. Venkatesh sir, and all the professors for having me here. And a very good evening to everyone, the students, professors, everybody who's listening here. I'm going to talk about, I'm going to give you an introduction on polyurethanes, their application, how they are synthesized, and move into the augmented role of automation in the chemical industry. To start a little about myself, I'm from the 2011-2015 batch that passed out from St. Joseph's. Got my bachelor's in chemical engineering. Immediately, I went on to pursue my master's in chemical engineering from Lamar University in Texas, USA. I graduated in May 2017, and after roaming around the country for 5 to 6 months searching for jobs, I was able to find a role as a plant engineer with Isotech International, and I've been working there since November 2017. To touch base about Isotech International, we manufacture custom polyurethane systems, and we've been in the business since the early 1980s. We are primarily based out of Atlanta, Georgia, and we have one other manufacturing facility that's around 120 kilometers north of our facility, and we have a few distribution centers across the United States to cater to the needs of our customers. Some of the products that we make include adhesives, jacuzzi coatings, insulation foam, struck bed liners, and artificial glue. Let's dwell a little deeper. Just like Professor Karthikeyan said, polyurethanes are two-part polymers which combine isocyanates with polyols. They can be thermosetting or thermoplastic, which means they either alter themselves or with heat, or they are immune to heat. One very common characteristic is they're highly hydrophobic, and this requires very cautious storage and incorporation measures when adding to the reaction vessel. The biggest advantage of using polyurethanes is it adds rigidity and tensile strength to the products. Most of what we do is as coatings or adhesives that strengthen the existing products. Some of the common products that the industry is known for using polyurethanes are gaskets, hoses, foam sponges, skateboard wheels, and automotive suspension bushings. Here's a simple reaction that shows how an isocyanate prepolymer, a prepolymer is isocyanate rich, that combines with polyol, and that gives a polyurethane. They fall under the category of reaction polymers that's formed by the reaction of two or more isocyanate groups or two or more hydroxyl group. I've underlined two here because they are polymers, which means the minimum number of groups that should be present is two. If it's one, they become monomer. The final product and its characteristics are highly malleable, which means that depending on the polymer chain length, the cross-link, and the flexibility of the segments, you can arrive at different products. The long chains with flexible segments give rise to elastic products, while rigid products can be obtained by a lot of cross-linking in the molecule. Intermediate cross-linking gives rise to foams. Coming to storage, handling, and incorporation of polyurethanes. Production raw materials in general must have adequate and proper storage methods. What it means is that right before a reaction is start or a reaction is commissioned, all the raw materials have to be stored in appropriate places so that they don't get damaged or their structural integrity is not compromised. It is highly recommended to store high moving raw materials in storage tanks or silos and be delivered directly to the reactors. This is both a cost-effective measure and in ease from an operator standpoint. Isocyanates are highly reactive chemicals, and like I said before, they are hydrophobic. They react adversely to moisture and water. Some of the common issues that we come across at Isotech are isocyanates sometimes are subjected to condensation and either increase in ambient temperature or decrease in ambient temperature can alter the chemical structure. So which means unless we have some proper handling and proper storage methods in place, this will definitely botch up the reaction, and the final product is going to fail quality control. MDIs, which stand for methylene diphenyl diisocyanate, they are stored and transported in drums under 5 degrees Celsius. It is very important to note that these are frozen, and it needs to be frozen up until the point that they have to be added. This is to prevent the formation of dimerization, which are insoluble white solids, which if added to a reaction or added to a batch can lead to very high viscosity and of course end up messing up the whole batch. We've studied in our coursework that there are 2 types of reactions. They can be both continuous and batch reactions. Continuous reactions are usually where the demand is really high and there needs to be a continuous production of chemicals, and you can see this commonly in petroleum industries. Polyurethane industries, to my knowledge, are mostly batch reactions because they cater specifically to a customer's need, and like it's mentioned here, it highly depends on the demand and supply equation of a company. At Isotech, all our products are batch processes. The biggest advantage that we have is the ability to have a tighter control over the reaction parameters. So even if anything were to go bad, all we have to do is press an emergency stop button, and either we discard the whole batch and we can restart, or we can do adjustments to current batch. This may not be possible in a continuous batch because it might end up messing up like long lengths and long volumes. I mean, a large volumes of the chemicals. Every batch produced is mixed and heated under nitrogen. It's very important to note that we need either nitrogen or argon because it helps in displacing air out of the reaction vessel. And air, if it contains moisture, again is going to be bad for the reaction and bad for the batch. Every raw material that we deliver to the reactor, we usually use pumps. It could be diaphragm pumps or gear pumps, and we also have ways of adding through vacuum, which is but vacuum is used only where the formulation is highly reactive and it needs much more closer scrutiny. And this is achieved by vacuuming the reactor and using the residual vacuum to send in the raw materials. So the polyurethane systems, we call it systems because it's 2 parts, isocyanate and polyol, or iso and poly. They generally fall into 3 categories. 1, customer specific products. The manufacturer develops products specific to customer application. That is where Isotech currently stands. We have our salesmen going and finding customers, or customers finding us online and asking us for, this is our application, this is what we wanted to do, and our chemists and the R&D department gets on it, finds a formulation, and see if it pleases the customer. Market specific products can be more called consumer products, which means that they already have a foothold in the market, and all we do is try to come up with a competitive product that could either increase our sales or give a better product to the customer. And the third common category is toll blending, which all we do is provide the means of production. The customer gives their formulation, they tell us what to do, and in some cases they even supply the raw materials, and all we do is mix them and complete the reaction for them. There is no product development involved in this stage. Uh, some of the projects that I worked on at Isotech are, uh, like I said, MDIs uh, need very uh, need very careful storage, and we had problems with dimerization in the past. So I designed a heated water bath to mitigate this dimerization issue. The ovens, the heater ovens that we currently have heat the air around the chemical, around the drum, or around the storage container, and it does so. This causes uneven heating, which leads to dimerization. So a heated water bath a heated water bath would have uniform heating throughout the whole vessel, and this helps in reducing the dimerization. And we were able to achieve 50 to 60% increased efficiency per drum. Um, a solvent recirculation system to subject cured adhesive in a filter housing to an industrial solvent. So we have a formulation where we make adhesives. It's you might have heard of it, super glue or gorilla glue, and right after the production is complete and packaging is done, the filter housing that is used gets set, or it becomes solidified once it comes into contact with moisture or air. So it's very important that this filter housing be cleaned before the next batch begins. And I was able to uh, design a system where a recirculation of industrial solvent was used to clean this process. Before that, the operator had to manually torch them, which means they had to use high heat or literally subject the filter housing to fire. This caused a lot of safety hazards, and it was not the right thing to do. Addition of pigments to a colorless finished product outside of a reactor using variable frequency drives and a static mixer. Usually, if a product is colored or not colored, everything takes place inside the reactor. We add the required raw materials into the reactor, and we mix for so long, heated, not heated, and it's all dispersed. But in a very specific case, I had to design a system where the color had to be added outside the reactor, because the reactor's capability had to be diversified. So the color was black pigment. So if the black pigment got added to the reactor, we usually maintain that reactor or use that reactor only for black pigments. But bringing it out made sure that we can use the reactor for other non-color chemicals as well. And I was able to achieve that using VFDs, which stand for variable frequency drive. It's an electronic device that helps control the speed of a motor in this case the speed of the pump, and it adjusts the flow rate accordingly. And static mixers are nothing but a small mixer segments that has coils around it, coils inside it, that increases the mixing. It's just a simple concept of uh, enhanced mass transfer, and that's how I was able to achieve it. And lastly, I designed an automated filling station that down packages finished goods from bulk to smaller containers like jugs and pails. Every chemical industry or every chemical company makes products in bulk. Like they sell by drums or totes or a tanker worth that can be uh, so many liters, and it usually goes by volumes. Down packaging is not something that's easier to do. when we got a customer who wanted us to both make the bulk product and down package it, it was a tedious process, because uh, we filled them in gallon jugs to manufacture 800 900 gallons, and to fill each one of them individually was a tiresome and time consuming process. And the automated filling station, all the operator had to do was place the jugs, press a button, and it gets filled. And that was my first exposure to automation. uh, Safety and precautions: when it comes to polyurethane or any chemical, uh, PPE is very important. Respirators are a must when handling isocyanates, and are highly recommended during the packaging and finishing of goods. Even during the regular handling of chemicals during the batch, we use high density polyethylene suits, so that it prevents damage to either your clothing, yourself. And we use face masks, so that there's no and we have some splash guards. uh, every reactor must be properly sized to install pressure relief valves to prevent overpressure scenarios. uh, this really comes into use when a new formulation is developed. Like, for the first time, it's not an easy process to, as an engineer, to think or foresee what could go wrong from a lab scale to a production scale. And if we don't have all these safety features installed, or uh, safety features already figured out, it might end up being a really bad case. And pressure and temperature gauges are also very important, because it helps to monitor and track a batch's parameters. This helps in adjusting the batch both from an R&D and engineering standpoint. Let's move on to automation in the chemical industry. Automation is of three types: fixed, programmable, and flexible. Fixed automation is where you have a certain product that needs to be made a certain way, and that's how it's going to be made always. So a biggest example for this would be uh, cars and uh, automobile manufacturers. So, for example, if they have a Toyota Corolla manufacturing in one line, it's going to, okay, not manufacture, but building. So it's going to build a Toyota Corolla always. You can't have Toyota Corolla and then a Toyota Fortuner, or a Toyota Camry, getting all of them putting together in one line. So that's fixed automation. So the programs are set, the robots know exactly what they want, and the parts are supplied. It's very important to know that the parts will be different from each vehicle. So that's why it's called fixed automation. Programmable automation is where you can to cite the same thing. So let's say the tires on on 5 different Toyota vehicles are all going to be the same, which means that up until the point tires get put together, they are fixed automation. And when it comes to tires, any car or any vehicle can go through this line, and it's easy to program accordingly. And this gives control uh, from from very specific instance to very specific instance. And flexible automation is where you can change the parameters right in the middle of production. And this is what I've usually worked on, where I can, so the one of the systems I designed can fill gallon jugs, it can go to pails, it can go to drums, which means it's flexible. It depending on, all I have to do is give the operator 3 different options, and he or she can press them, and the program takes care of it. Coming to automation in the chemical industry, it's having an ever-growing presence. And though automation has been present in some kind, it is not it is not it is not fully implemented as we would like. But two of the most common challenges that we come across are large-scale industrial reactors and equipment like heat exchangers, vacuum traps, etc. They've all been in use for a long time. It's not easy to make modifications to design, and automate them as we would like. So that's one of the issues or one of the challenges that we face when it comes to automation. And Isotech is a very small company, and we have a lot of small chemical manufacturers in the world. So even if an equipment can be automated, the cost of an automation project might not justify the return on investment. And just to give you an example, the automated filling system I designed was like $15,000. And right now, even though the production has gone up, but when I designed it a year ago, $15,000 took some convincing, and I had to show my boss why it is right and why it was the right way to go. And we have some reactors that have been sitting in our plant for like 30 years. And to automate just one mid-sized reactor, it costs $50,000 to $60,000, and even then you would need some operator intervention to complete a reaction. But the biggest advantage of automation is the reduction in human error. Uh, we can also have remote control, remote monitoring, and troubleshooting, along with better process control and safety. The automation projects that we have, my supervisor and I, we are able to sit in our office and control the parameters. Of course, we don't control the opening and closing of valves or change the weights, but if we have to, we will be able to. This helps where there are really big chemical plants, and you cannot be expected to go and inspect every single time there is an issue or you want to do a modification. And that's where automation, I believe, has as a very big advantage. Some of the examples that I worked on and I can show you today is the addition of raw materials to the reactor. Right now, I'm working on a project where every silo in my plant can be or should be able to deliver products directly to the reactor, and directly to the reactor. Right now, we have most of our products getting added from drums or totes. A fully automated system incorporates the required amount directly from the storage tank with the press of a button. And you have to imagine that there's going to be long lengths of pipelines. And if an operator has to individually go and open and close these valves, it's both time consuming and it could be prone to error. And that is the main issue. That is the main goal here, to prevent errors. And safety measures are much easier to implement when you have automation in when the equipment and the reactors are automated. Just to give you an example, the contents of a reactor needs to be heated to 100 degrees Celsius. And if the system was not operated, the operator would have to turn off the heater once the temperature reaches that point and turn it back on if the temperature drops. An automated system would take care of it by itself. So it knows that, okay, when it hits 100, I need to turn it off. And when it goes below a certain temperature, it turns it back on, and it's able to give us that control without the operator can be on his break, and the system would take care of it. When dealing with new formulations and scaling up, unexpected side reactions could lead to overpressure or overheating scenarios. Exotherm is something that on a lab scale we may not be able to notice, because on a lab scale they use very small quantities to complete a reaction. But when it comes to production scale, it could pose a threat. And this can be quickly mitigated with automation that would immediately supply coolants necessary to control the reaction temperature or turn off the heater. Chemical engineers and automation. Though we have been exposed to electronics and electricals, and we've been to all those EEE and ECE labs, it is still not it's still not our forte. We as chemical engineers do not primarily involve ourselves on the automation side of things. But what I learned it the hard way was, if you know automation, if you can understand automation, and if you can make yourself well-versed, it makes you more employable. And I've seen it firsthand. I've had it's easier to implement automation than we think it is, because chemical engineering is one of the toughest engineering courses out there, and if we can uh, do that, automation should be an easier task for us. And I highly recommend uh, for us to at least, or for you students to at least get an introduction to automation. Automation, of course, has a lot of programming. Programming is how we achieve automation. It's easy to throw around the word automation, and what we see outside is just the press of a button and everything gets done. But what goes on in the background is much more than what we see. And programmable logic controllers. I can't remember if we were ever exposed to this in our coursework, but PLCs are how automation is achieved, and ladder logic is the program, just like C++, that we use to control these PLCs. Some of the industry leaders are Alan Bradley, Siemens, General Electric, Schneider, and Mitsubishi. What I would like to put a request to the Department of Chemical Engineering is, if we could incorporate, if it's not there already, and if we could have either a certification course or one whole course in a semester about PLCs, I'm pretty sure our students will greatly benefit from it. And I'm not sure if electives are still electives or the department chooses it for us, but I strongly recommend PLCs and an introductory experience to automation. Opto 22 is an automation solutions provider. It's an up and coming automation company that uses flowcharts for programming instead of C++ or regular programming. This is what we use at Isotech, since it's much easier to program and much easier to understand. And one more advantage we have with Opto 22 is we have human machine interface, which helps the operator to see what's going on, and you can visually represent what's going on in the reactor or in the system. Though they're relatively less known, they're gaining a foothold in the industry. And just to give you a tidbit, James Cameron went to, or had a voyage to, the Mariana Trench, which is the deepest point in the Pacific Ocean, and he had a submarine built with Opto 22 products. So that concludes my technical sharing of knowledge, and let me get into how you can make yourself better. Like it says here, you need to increase your visibility. It's very important to work outside your regular coursework to become more employable. We have the knowledge, we have 4 years of knowledge, but there needs to be effort beyond that knowledge to make ourselves or sell ourselves in the market. To be very frank, we need to know PIDs, and we need to be able to implement PIDs, and piping and instrumentation diagram, and CAD. CAD is becoming a very common tool that everybody needs to know. Aspen, MATLAB, and COMSOL, this is more towards process engineering and the petroleum industry, but we need to have an understanding of that. Ladder logic, just like I explained before, is about PLCs, and knowledge on that makes you more employable because the world is moving towards automation. Six Sigma and lean manufacturing, though this does not fall under chemical engineering, it still is an industrial engineering concept, but it makes us understand how things go on the production floor. Project management. Project management encapsulate all these things about every single aspect of a project. So it could be procurement of raw materials or procurement of equipment, up until the point you send it to the customer, troubleshooting and maintenance. And project management, we have courses in project management, and PMPs, project management professionals, are needed more than ever right now. And the last point I've stressed here is shadowing. What is shadowing? Like, when I was in St. Joseph's, all I did was go to the class, finish my exams. I passed. I was happy. I did not do one thing that made me more employable or made an employer want me. So that's where shadowing comes into effect. you have to go and talk to people who are currently successful or currently working in the industry. Talk to them, ask them what they did, ask them if you can take a look at their plans. And it may be a one-day visit, but it's important to talk to people who are already having that knowledge. Every professor in our department is highly knowledgeable, and I'm pretty sure if you ask them, they'll guide you in the right way. Uh, I failed to uh, take that uh, take that advantage, or I failed to make use of it. But please don't make the same mistake I did. Uh, to end with my transition, the aptitude tests, which I believe would still be happening with respect to placement, they had a very big effect in how my life turned out. And when I was in St. Joseph's, all I thought was this is useless and it's a time waste. But the structured approach of St. Joseph really helped me turn me into what I am today. It helped me crack my GRE, get a good score in TOEFL, uh, and helped me with my university application. And of course, doing all that got me a good letter of recommendation from the professors. And the statement of purpose is how you get into the universities. And these aptitude tests played a big role. And when I came to the US, it was more of a cultural shock. And it took time to get adjusted to way people think here, their accent, and how things are perceived here. And I think that would be one big challenge everybody would face when they move out of the country. And the US education system is not as tight as the Indian education system. And to be honest, we were handed in plates in St. Joseph, literally, like everything we needed, we got it. Like they said, you choose, we do it. So they did it, but I never appreciated it. And when I came to the US, I understood how things were really easy for me in St. Joseph, and I failed to make use of it. Uh, when it comes to job search, LinkedIn and LinkedIn Learning and the online learning website Coursera. So you got to make use of all these tools that are available. They were available 5 years ago, but nobody cared. But they have a growing presence and a strong foothold today. And you, like I said, you need to make yourself more employable and put your effort on the knowledge that you've gained at St. Joseph. And coming to visa and immigrations, everybody is hearing about it. It's a big issue here in the U.S. And to everyone who would like to come to the U.S., I strongly suggest don't try to get into the US this year or the next year. This year, because of Corona, things are looking really bad from an immigration and visa standpoint. And next year, you want to see how this presidency turns out. It doesn't matter if President Trump gets elected or not elected, but we need to give the either the new administration or the current administration 1 year to see how they bring changes post-Corona to visa and immigration. I hope I did not bore out any of you here, but here's the conclusion. Polyurethanes are polymers, two monomers at least two monomers that are synthesized by reacting isocyanates with polyols. They require careful handling and storage, and they tend to be hydrophobic. Uh, PPEs are always a must. Automation is slowly gaining a foothold in the chemical industry. Every existing system, though it will have its own challenges, can be automated. Programmable logic controllers are the most common way automation is achieved in today's world. Here are my contact details. You can email me or send me a request on LinkedIn. But when you send me a request on LinkedIn, please be sure to include a small message. I don't tend to accept anyone and everyone. So please do that, and we can connect. And feel free to share feedback, comments, and ask me any questions. And if you thought, you professors or students thought something I said was wrong, either information wise or any otherwise, if you felt something was incorrect, please feel free to share that with me. I always like to take constructive criticism. That's how we improve. Thank you for your time. It was an honor.
Can you hear my voice?
Yes, ma'am.
Yeah, can I just start with the questions?
Yeah, of course.
Yeah, the first question is, what are the advantages of polyurethane over plastics?
Um, to be honest, plastics have an environmental factor to it. So, and plastics always they they react to heat, and of course they can damage the environment. I'm not saying polyurethanes are highly bio friendly, but they are much more they're much more friendly than plastics, and plastics cannot they don't they don't add tensile strength or rigidity as much as polyurethanes do, and that's where I think polyurethanes are a better option.
Okay, the next question is, will polyurethane become hard or fragile over the years?
I think polyurethanes are hard or fragile to start with. I mean, not fragile, but they're by hard. Do they mean brittle? I'm not sure. But over time, they could become brittle depending on what it is. For example, if it's a gasket that goes between two high pressurizing equipment, yeah, over time it's going to become brittle or useless. Um, so by hard, I think that's what they mean. What was the other part? Harder
Hard
what?
and fragile.
Uh, Fragile. It might be because of the temperature conditions and the varying temperatures. Because here in the U.S., if you go to New York, it's 0 degrees or less for 7-8 months a year. But if you're in Texas, it never gets to even 10-15 degrees Celsius. So the same product can have two different uh, reactions or two different ways it shows itself over time. With temperature, yeah, that could happen, but it's not something very common.
And the next question is, will automation in chemical industry reduce the need for manual power?
No, it is in chemical industry. I would say you would definitely need someone monitoring, and by someone, I'm not telling who's in an engineering capacity, but uh, it will be from an operator standpoint, even if it's completely automated, which is not it's not that easy. It might be press of a button. I have chemicals delivered from my storage tank, press of a button. I have my mixer starting, press of a button. I have the temperature control, but you still need somebody to press that button. uh, you cannot remote press a button. It would not be wise to have somebody sitting 10 kilometers from here to press a button. And though it can be done, it is being done. It is only where there's absolutely no manual intervention. But this is not a displacement of the workforce, but only a way to help them out.
The next question is polyurethane foam safe to use?
Yeah, of course they are. Like I work in environment where we have foams we use for insulation, so they are definitely safe to use.
And the next question is, how much heat can the polyurethane take?
It depends on what polyurethane that you're handling. If it is an adhesive, you we I only have Fahrenheit. Um, Please forgive me, but we manufacture, and we the reactions complete under 250 300 Fahrenheit, and once it solidifies, the adhesives are transferred into small tubes. So the customer again subjects it to 300 400 degree Fahrenheit uh, to melt them. So again, it depends on the formulation. There are some that can take how much ever it can, or there are some that can melt so quick. So it can be thermosetting or thermoplastic.
And the next question is, how much energy could be saved during the usage of polyurethanes?
Um, so when polyurethanes are used for insulation, uh, you can save a substantial amount of energy. And if you ask me in percentage or how How much exactly? I don't have that details, but I can only say that uh, every we have some temperature sensitive products, and we have production rooms that have polyurethane foams and insulation all over. And I can say that, okay, if the temperature is 100 degrees Celsius outside, which is too much, it's going to make it 20 degrees Celsius. But it does have its advantages. And
And
I'm
then,
sorry, I don't have an answer for how much exactly.
and the last question is, are there any particular software which are available that a chemical engineer should be equipped with?
I'm sorry, could you repeat the last part, please?
Are there any specific software a chemical engineer should be equipped with?
Um, 1 second, please. Yes, you need to definitely understand Aspen and MATLAB, because they're very common. I would say every chemical engineer has to, at least, if not know how to exactly work with it, but at least know what they are. And 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 what the one thing an employer definitely looks in every candidate is the attitude. Skills can be taught. Like I had no exposure to PLCs, and today I'm programming PLCs, and I'm a chemical engineer. So so you should have that open mindedness to start with. And Aspen and MATLAB, I would say COMSOL, depending on where you're taking your career, and CAD. And I cannot stress this enough, CAD is very important. I believe we had 2 courses of CAD, at least when I was in St. Joseph. At least we had 2 courses of CAD, which we went to the mechanical engineering department and did. And though it comes under mechanical engineering, it's more used by them or civil engineers. Doesn't mean chemical engineers cannot use it. So if your coursework does not permit CAD, uh, get get either get a trial or demo version and look at YouTube for videos and learn CAD. And I cannot stress this enough, CAD. If you ask me for one software that's very important for engineers, CAD.
Okay, thank you, Pradeep. Thank you for answering all the questions which has been asked from participants.
Of course, thank you very much for having me.
Okay, thanks for your valuable time, Pradeep. I want to conclude this session with a vote of thanks. I would like to express our sincere thanks to our guest, Mr. Pradeep Murali, for sharing his valuable ideas about polyurethane in this webinar. I would also like to thank our beloved HODs for their moral support and guidance. I'm very happy to express my vote of thanks to our staff members for their valuable suggestion and participants who have made this webinar a great success. Thank you. Thank you all.
Thank you.